This podcast is for general information only. It is not intended as a substitute for general healthcare services. If you have medical conditions, you need to see your doctor. Use of this information is at the user's own risk. Welcome to FitRx with Dr. Greg Dennis. Join me as we challenge the standard sick model of healthcare. This is your source for everything health, wellness, prevention, fitness, biohacking, and more. Hello, everyone. Welcome to another edition of FitRx. I'm your host, Dr. Greg Dennis. And like a lot of times on this podcast in the past, I've been very, very fortunate to have some really smart people on here that I have learned a lot from. And today's guest is no exception. Dr. Richard Johnson is my guest. He is a nephrologist, which I have found over the years that just from the understanding of the body and physiology, nephrologists seem to be at the top of the pack on just intelligence and the understanding of that. That's just kind of been my experience. But anyways,
I hope I don't disappoint you.
I met Dr. Johnson at Low Carb Denver. And he gave a phenomenal lecture, which we are going to talk about today. But he is a professor of medicine at the University of Colorado. He is a clinician, educator, and researcher, board certified in internal medicine, infectious disease, and kidney disease. He is the founding editor of Comprehensive Clinical Nephrology, which was one of the main textbooks on kidney disease. He has led research the last 20 years on the cause of obesity and diabetes, with special interest in the role of sugar, especially fructose, which we're going to talk about, and uric acid. And he's also written several books, The Sugar Fix and The Fat Switch, and more recently, one called Nature Wants Us to Be Fat. And so I'm anxious to get into that a little bit too. So just a really, really smart guy, really just honored to have him on. So Dr. Johnson, welcome to the show.
Hi, Greg. It's great to be on your show. And thank you for that really nice introduction.
Well, yeah.
Also, of course, but
if you will, to start out, I guess, tell us just kind of how you got here and interested, how you got interested in sugar and in fructose and in the studies that you do as, you know, starting off, I'm assuming kind of a conventional nephrologist, and just what, talk about your evolution and then what led you to kind of studying these specific things.
Well, my father was a researcher in medicine. And when I went through medical school, I always thought that I always enjoyed research as well. So I kind of wanted a career where I would see patients, but also have a research side. And I became interested in kidney disease along with general internal medicine, just because of the comment you made about physiology. And the kidney docs really have to understand the physiology, because the kidneys control your fluids, your electrolytes, your blood pressure. And when I started, I've been doing clinical medicine for 30 plus years, but I've also been doing research. And initially my research was on kidney disease because it made sense, because I'm a kidney doctor. And then I had the insight to know that, all the data suggested that the kidneys play a very important role in blood pressure as well. And it was known a long time ago that if you took an animal that had high blood pressure and you transplanted its kidney to a normal animal, that animal would develop hypertension. So it was known that hypertension travels with the kidney. So the question was, what is it about the kidney that can increase, that is altered to cause high blood pressure? And, and high blood pressure is such a major problem in this world. 1/3 of the population have hypertension. And yet 100 years ago, it was really only about 5%. 120 years ago, about 5% of the population had hypertension. So there was a mystery, what had happened in the last 100 years to explain why people are developing high blood pressure. And it isn't just because people are living longer. There are a lot of children developing hypertension, teenagers, and often with obesity and prediabetes. It's sort of like a triad. So I became interested in that, and we had this major insight that the kidneys of most people with high blood pressure start off being normal and they can excrete salt quite well. But over time, when you start becoming hypertensive, you have a little bit of difficulty excreting salt. And so the question was, why was that? And people were measuring hormones, but I started looking at it and realized that there were small structural changes in the kidney that were leading to hypertension. Sorry, this story's going on a bit. But anyway, so I was, looking for it, and we identified that if you could create small changes in the blood vessels and in the kidney, an animal could become permanently hypertensive. And so when we published this a kind of a review of this in the New England Journal, and made the case that high blood pressure is actually due to subtle damage to the kidneys. And it still seems to be the most likely mechanism. It stood the time since 1998 when the review was published. So then the question was, well, okay, Rick, if subtle kidney damage is the cause of hypertension, what's causing the subtle kidney damage? And there was a lot of talk about uric acid. Uric acid is very high in people with high blood pressure. And it was known that people with gout, uric acid causes the disease gout. And uric acid is a substance that everybody has in their blood. But in some people, it can be really high. And when it's high, it causes gout. Well, when it's high, it's also associated with the development of hypertension. And there were all these papers that said that people with gout got low-grade damage to their kidneys. And I said, oh my gosh, could it be that gout might cause maybe the crystals in gout that cause the joint pains, maybe they're also forming in the kidney, and that would be enough to cause the subtle kidney damage and then make people sensitive to salt and cause hypertension. So I said, could it be that uric acid could have a role in hypertension? And I was contacted, Merck had just come out with this drug, losartan, which can lower uric acid besides blocking the angiotensin system. And they were interested in trying to figure out if uric acid did anything. So they gave me some money to do research. And I decided to take rats and raise their uric acid and see if I could generate crystals in their kidneys that might cause hypertension. So I raised uric acid in the animals, and they got some low-grade kidney damage, but we didn't, in that experiment, we didn't measure the blood pressure, but we didn't see any crystals. And everyone in my lab, I went to them and said, okay, we got to repeat the experiment and measure blood pressure. And no one wanted to do it. But finally, one lady, Marilda Mazzali from Brazil, decided to do it. And she came to me about 3 weeks later and said, hey, Rick, the animals are developing hypertension. I go, really? That can't be. If uric acid caused hypertension, the world should know it. It's been around a long time, but no one had really done that experiment. And so we ended up doing like 100 animals. And after doing all 100 animals, whenever we raised the uric acid, they would develop high blood pressure. And if we lowered the uric acid, we could lower blood pressure. So then we came to the conclusion that uric acid might actually have a role in hypertension, and certainly it was high in about 50 to 70% of people with hypertension. So that's how I started studying uric acid. So then the next question was, I started looking and I realized that serum uric acid levels had been increasing progressively in our population over the last 100 years. And when back 100 years ago, when blood pressure was not so high, uric acid levels were like 3 or 4 in the average person. And today they're like 5 or 6. And some people have levels of 7, 8, 9, 10, and they get gout, but there's also a very high association with hypertension. So then I said, oh gosh, the uric acid's going up in our population. It's probably related to diet. What in the diet could raise uric acid? And everyone was saying, well, it's purines. And purines are these nitrogen containing substances that are like in beer and in meats but meat intake really hadn't increased during this time, and beer had gone up a little bit, but it certainly couldn't explain hypertension. But there was another food that is associated with high uric acid, and it's sugar. And sugar is carbohydrate, but it consists of two sugars. Actually, it's glucose and fructose bound together. And glucose and fructose are bound together. They make up sucrose or table sugar. And when you eat sugar, you start producing uric acid within minutes, 10 minutes, it's already going up in your blood. And it's not because of the glucose, it's because of the fructose. And so I said, okay, I got it. We're going to give sugar to an animal and we're going to see if it raises its blood pressure. And so we gave sugar to some rats and their blood pressure went up, and we lowered their uric acid and their blood pressure came down. Everything looked great. But there was one other thing that happened. When we lowered the uric acid, the animals also, even though they were eating the same amount, they didn't get as fat. And the triglycerides in their blood didn't go up so much. And their fatty liver was less. And everything was better. They were more insulin sensitive. I go, what? Could uric acid actually be playing a role in obesity and metabolic syndrome? I can't believe it. And yet, as we started continuing to study this, and we studied in great detail, we actually identified that this was the major mechanism by which sugar causes hypertension, as well as obesity, as well as metabolic syndrome. And then we had this big discovery that fructose was not only from the sugar we eat and from the high fructose corn syrup we eat, but that our body can make fructose. And when we're eating bread and rice, our body makes fructose, and that makes uric acid, and that triggers all these events. And then we started realizing that we identified an absolutely major pathway for what causes obesity. And then, it goes on from there. But basically, I was a kidney doctor following my own curiosity, trying to figure out what was causing high blood pressure. It took me to kidney damage and took me to uric acid, then took me to sugar. And then suddenly I realized it was a much bigger story than I'd ever had anticipated. And for the last 25 years, I've been studying sugar and fructose, and I'm kind of an expert on it. I've probably published 200 papers on this topic. And so that's why I wrote this book, Nature Wants Us to Be Fat, because it turns out that this is a very major pathway that animals use in the wild to get fat before they hibernate. And birds use it to get fat before they migrate. It's like a mechanism for causing obesity.
Yeah, that's fascinating.
Yeah. So that's the story. And it turns out it's even bigger because we now have linked it with how it can drive cancer and dementia and alcoholism. And I'm funded by the National Institute of Health to study these diseases and how fructose can be involved in it. So it's kind of like unraveling a big story, and it also helps to explain the various diets. It can explain why low carb diets work, and why protein leverage, high protein diets are beneficial. There's a lot of benefits a lot of things that this pathway can explain. So it's sort of,
at the conference, you went through the physiology of basically how that works, everything you just described of how increase in fructose elevate your uric acid level, which we don't need to do that. I mean, the listeners probably don't care about the nuts and bolts of that, but several questions regarding that, just, from a primary care perspective. One, if, I preach a lot of metabolic health. Okay. So I'm checking a lot of fasting insulin levels, and obviously, blood sugar, and we look at triglyceride levels and stuff like that. I typically don't check uric acid levels. Should clinicians like myself be looking at that more, or can it just be a given that if somebody has high insulin levels and high triglycerides, most likely they're also going to have high uric acid levels. Are those all kind of together?
Yeah, they are all together. And, there's, I sometimes will show a slide, and like the prevalence of high blood pressure goes up stepwise as the uric acid goes up, and the prevalence of obesity and the prevalence of diabetes, it goes up step by step. So if you have a uric acid of 8, for example, you may have like a 70 or 80% chance of being obese. And if your uric acid's 10, it's like 90%. It's like a line. So there is a relationship. But, our data suggests that uric acid is actually playing at least part of a role in this whole pathway. And lowering uric acid should be, we believe, will be, beneficial, just like helping to improve insulin resistance and things like this. And in fact, when you lower uric acid, and we did a clinical trial, we did improve insulin resistance by lowering uric acid. So what I like to do, what I would recommend, and I'm sure we converge, I'm certain of it, that the foods that you are telling people to reduce are the same foods that I'm telling people to reduce, and that we are in alignment. And what's interesting is a lot of the foods that we reduce will lower uric acid, especially inside the cell where it counts. Although the serum uric acid is kind of like the iceberg, the tip of the iceberg. It shows what's out in the serum, but you can have a high uric acid inside the cell, and it may not be that high outside the cell. So you can disconnect them. So, for example, if you eat like carbs, like bread and rice, they won't raise uric acid in the blood very much, but they do stimulate uric acid production inside the cell. And so bread and rice and potatoes, especially if they're salted, can activate this process that makes fructose in the body. And then the fructose, when it's metabolates, generates uric acid. And then the uric acid, is one of the drivers. And there's some simple things you can do. So I recommend measuring uric acid. And, a normal should be under 5. And 5 to 6 is kind of a gray zone. And over 6 is beginning to get high. And when it goes over 7, your risk for gout goes up, but so does your risk for developing kidney disease, high blood pressure, diabetes, obesity, fatty liver. A high uric acid is a predictor. And so we did a study. If you have a high uric acid and you don't have any other risk factors, within 5 years, you have more than a 2 times increased risk for developing obesity, diabetes, hypertension, kidney disease. So it's a true risk factor. And I think it's worth measuring. And there's some simple things you can do to help lower it. So some of the simplest ones is vitamin C. Everyone knows vitamin C is good, right? Well, it really is a good vitamin. I mean, it's true you don't want to eat grams of it because it can cause kidney stones. If you're eating grams, it can cause oxalate stones because one of the metabolites can make oxalate. But if you're just taking 500 milligrams a day, or maybe even a gram a day, in general, that's like a great way. It will lower uric acid by a point or 2. And it's been shown in placebo-controlled trials. It's really it's a simple, it's a healthy, and so that's a good way to do it. Certain fruits are high in vitamin C and low in fructose. So fructose is the sugar that makes fruit sweet, but like lemons and limes and kiwi don't have much sugar in it, but they have a fair amount of vitamin C, especially kiwi. So kiwi is a great fruit, natural fruit. It turns out that natural fruits are in modest amounts, where you're not eating huge amounts. You're not going to get that much fructose. I mean, if you eat 6 oranges at one setting or make a juice or something, you're asking for a lot of fructose, then it's almost like a can of soda. So don't drink fruit juice, but like a natural fruit that's kind of lower in sugar, lower in fructose, has vitamin C, and it has a lot of other things that combat fructose as well, like flavonols, epicatechin, all these, there's a lot of good fiber, a lot of good things in natural fruit. So I do recommend, and we even did a trial of a low fructose diet with or without natural fruit supplements. The natural fruit supplements actually did a little better because it was a more tolerable diet. People liked it. So anyway, vitamin C, drink more water. Believe it or not, uric acid goes up when you're dehydrated. When you're dehydrated, your whole body, all the bad things go up in your blood, really. And it's not good. And we can show that dehydration stimulates fructose production. So dehydration, you did it right. You just drank some water. I wish I had my bottle with me. Honestly, it's, you see all these people running around drinking water and they're skinny, and you go, it's almost like a group of subset of the population.
Right.
And it's real. That's real. The drinking of the water is very healthy. Another thing you can do to drop your uric acid is to cut back on foods that really drive uric acid up. And the biggest culprit is beer. Now, I know there's some people listening who are probably unhappy with me to say this, because a lot of people just love beer.
You just lost half the audience. They just shut you off.
I'm really sorry. All my friends in college, they all brew beer. They all love beer. I went to the University of Wisconsin, beer is like the favorite college drink. But I will say that beer, it isn't just the alcohol. Alcohol raises uric acid. So if you drink a lot of whiskey or hard liquor, that will definitely drive up uric acid. And then the hard liquor, you can mix it with sugar, pina coladas and stuff. That's not good. That will raise your uric acid. But beer, what's the trap behind beer is it's not the alcohol so much. It's the brewer's yeast, which is just rich in little nuclei, little cells that when they break down the DNA and the RNA, and it gets broken down to uric acid. So brewer's yeast is like really, it's the brewer's yeast. In fact, non-alcoholic beer will raise uric acid, just like regular beer. So anyway, so if you can cut back on beer or switch to, a different kind of alcohol drink, like wine, for example, would be although there's sugary wines too. So there's like sweet wines, and I don't recommend that. But anyway, but beer is a big culprit. And shellfish, which what person doesn't like shrimp? Most people love shrimp and seafood, and there's a lot of good things about seafood, especially like fish and stuff. But the really rich shellfish like shrimp, crab, lobster, oysters, all those things that we really love, they will raise uric acid if you eat a lot of them. So the trick is to reduce your portions or eat them less often, So those are some of the things that I recommend to lower uric acid. There's also other tricks to lower uric acid. But I think these are good starters. And but uric acid is probably a player.
Okay. So you're not recommending people not eat fruit, because when I think of fructose, of course you think of fruit, but you're saying just pick your fruit wisely. Is that correct?
Yeah. And, in my book, I have a table showing the relative sugar contents in fruit, and also, which ones are particularly rich in vitamin C and things like that. And, as a fruit ripens, the sugar content goes up, and the vitamin C content tends to go down. So what happens is, like the animals that use fruit to gain weight, like bears, will eat the fruit to make them hungry. Actually, if you, the trick behind fructose is it's not the fructose that makes you fat. Fructose makes you hungry and eat more. And what they do is they eat lots of fruit at one setting. So like if you're an orangutan and you want to gain fat, they'll eat 100 fruit at one setting, or 1,000, 5,000 berries in 24 hours for the bear, And so they're eating huge amounts. When we eat one fruit, we're getting like 3 or 4 grams of fructose. And a lot of that is removed in the intestine. There's kind of like, we call it the shield. It will remove about 3 or 4 grams of fructose. And so you don't get a lot of fructose to your liver where all the action is when you eat a natural fruit. Now, if you eat a bowl of grapes, or if you eat like a lot of fruit all at once, yeah, you can overcome it. But in general, natural fruits are going to turn out to be healthy. There's some fruits that are unfortunately really rich in sugar. The worst one are figs and dates. And they're pretty much concentrated sugar and fructose. So you can get a fair amount. And a lot of people love those fruits because they're classic for the person who's hiking, or and it goes back to the ancient days when people would cross deserts. They would wear these fig strings. But what would happen is it helps to store fat, which helps you for your trip. So because fructose activates the process where you start to store fat.
Where are bananas on that list?
Well, bananas don't have that much fructose themselves, but they are pretty glucose rich. And what happens is, do you have a glucose monitor? Do you ever use one of those things?
I have in the past. Yes.
Yeah. So everybody's different, and some people can eat a piece of bread and their glucose levels hardly go up at all. And other people, they can eat a piece of bread and their glucose levels can go up transiently, like by 30 milligrams. And that triggers insulin. It also triggers the conversion to fructose. So you don't want to have big swings of glucose after you eat. And that's, because it stimulates insulin. You and I know insulin's not good to have high levels, but it also stimulates the fructose production. Yeah. So, so when you eat a banana, I decided to kind of test which foods were good for me and which ones were not. And my favorite breakfast for years was a little bit of oatmeal with sliced banana, no sugar. And I thought I was healthy, but I found to my disappointment that the oatmeal actually raised my glucose a little bit. But when I added the banana, it really went up. So even though the banana doesn't have that much fructose itself, it makes my glucose go up high enough that it stimulates insulin and fructose production. So I have to be very careful with bananas.
Gotcha. Yeah. Makes sense.
Yeah.
Well, what's your advice on, because most people, when they think of uric acid and gout, and more traditional advice is, stay away from red meat. And certainly they mention beer and the shellfish and that kind of thing. But we don't ever hear anything about, well, stay away from fructose. And so it sounds like what you're saying is that's probably more important. And maybe we can eat meat and that other stuff, especially if we, monitor our fructose and sugar levels. And so kind of what's your advice on that? And then I guess the second part of that question is, which with you offering that, which again, you don't traditionally hear, how have your colleagues received that? Because I don't ever hear any other doctors talking about fructose and sugar, especially as it pertains to gout.
Yes. Okay. So let's go through. There's quite a few questions there. So let me just say again that, the data is very, very strong that fructose can activate a switch that makes us fat. And the way the fructose works is it generates uric acid, and then the uric acid, along with some other things, suppress our ATP production or energy production from the mitochondria. And when that happens, that makes us hungry and we eat more and we start storing fat, and it triggers this big biologic switch that makes us want to gain fat. And so based upon that data, fructose and uric acid look like they're bad. And most fructose, the only way you can get fructose is you either eat it or you make it. And when you make it, you're making it from glucose. That's the only way you can make it. So, so you can eat fructose like sugar and high fructose corn syrup, and those foods are bad. So if you see a processed food filled with sugar and high fructose corn syrup, that's bad. But you can also make fructose from glucose. So things like bread, rice, potatoes, salted French fries, those kinds of things can be converted to fructose in the body. So on that basis, fructose is mainly from carbs. It's either from glucose or fructose. And this explains why low carb diets are so beneficial, because they're reducing the carbs that stimulate insulin, but they're also reducing the carbs that get converted or contain fructose. But I told you that uric acid has a role in how this works. And you bring up the fact that, yeah, but doesn't uric acid be generated from, not just seafood, but it can be generated from red meats. And it turns out that it can be generated from red meats, especially processed red meats. And when you process red meat and you do all these treatments to it, what happens is the meat starts to break down a little bit, and it releases glutamates. And the glutamates can be converted into uric acid, rather, not fructose, but into uric acid. And also the meats can contain nuclei that can break down and generate uric acid. So when you're eating meats, especially processed red meats, you can generate uric acid. And when the uric acid's high enough, you can get gout. So theoretically, red meats might also be a risk factor for obesity. And yet we have people on carnivore diets that they're certainly not getting fat. And so the question is, what is this disconnect? And what it turns out is that the uric acid not only is triggering this biologic switch, but it actually works, a lot of it, the way it works is by stimulating the conversion of glucose to fructose. So it's actually involved in the conversion of glucose to fructose. So if I eat bacon with in a cheeseburger, the bun gives me the glucose, and the bacon generates some uric acid that helps convert the glucose to fructose. And I get the double whammy, because then the fructose is making more uric acid, and the whole thing just triggers it. It's like a bomb. But on the other hand, if I'm on a low carb diet and I eat red meat and I start generating uric acid, yes, the uric acid will have some effects on its own, but as a lot of its effects are to convert glucose to fructose. But since I'm on a low carb diet and I'm on a carnivore diet, I don't have the carbs to convert to the fructose. So it's sort of like a bullet, but with an empty gun. I mean, an empty gun, I guess, because you got the uric acid, but it's not doing as much as it could if you had carbs present. So the answer is yes, you can raise your uric acid with red meats. Yes, that can trigger gout, because if the uric acid goes up high, you can get gout. If you're on a low carb diet, so that you're on a high protein diet, yes, your uric acid could go up and you could still get gout. But the relationship of uric acid to obesity and diabetes is blunted because you're on a low carb diet. And so long as you don't have the carbs, you don't have the fructose that you're going to either make or that's in the carbs. And so it protects you a little bit from that. Now, having said this, sugar is well known to trigger gout. And when I went back into the literature, I found that Sir William Osler, the father of modern medicine, wrote in his famous textbooks how critically important it was for people who have gout to avoid eating sugar and fruits. They even pointed out that things like fruits could precipitate a gout attack. And if you talk to people with gout, they will tell you that they do notice that there's often notice a relationship with sugar as a risk factor for triggering an attack. So it's not just, that duck and beer. It can also be, that rich dessert. So, and as a person who has actually managed many, many patients with gout, I can tell you that sugar is an initiator, and many, many people recognize this. So anyway, yes, there is a relationship of sugar with gout. It wasn't emphasized when we went to medical school. It was all about high purine foods and alcohol. But if you talk to rheumatologists now, they are very well aware of this association, and it's part of the plan to reduce gout attacks is to cut back on sugar, cut back on high fructose corn syrup, cut back on purine, really red, but especially processed meats, glutamate rich meats, back off on alcohol, especially beer, and sugary alcohol containing drinks. Sadly, it's a lot of foods that many people love and feel addicted to. So good luck. But I think that if we know that the food's not good for us, we can develop ways to beat it. And things like intermittent fasting, low carb diets, all these approaches are great.
Okay. You mentioned at the beginning about this elevated uric acid can cause some kidney damage, which can then cause hypertension.
Right.
So I'm wondering, in the patients that you've seen and treated, by lowering the uric acid, can that kidney damage be reversed?
Yeah. So, this is a very controversial topic. So now we can talk about the controversies on uric acid. And there's super, super strong associations, maybe over 50 studies that show if you have a high uric acid, that it increases your risk for kidney disease. And there's many experimental studies showing that when you raise uric acid in animals, they develop low-grade kidney disease. And if you treat it, you can block the development of kidney disease. Blocking the development of kidney disease is very easy to do with uric acid. On the other hand, treating your already pre-existing kidney disease is a little bit more challenging. And there are definitely many trials that do show benefit if you can extend the treatment for 2 or 3 years. The trouble is a lot of studies are only 6 months or 1 year. And sometimes it's hard to show a benefit in that period of time. And these days we're getting so good at treating kidney disease that really, in order to show a benefit, you have to have the control group worsen. And if the control group is stable, it's hard to show an effect. So it turns out that it's harder to show a benefit of lowering uric acid in people with mild, stable chronic kidney disease. But there are many trials that show benefit, particularly in people whose kidney disease is actively getting worse. And there's more and more data that people with gout, for example, have uric acid crystals in their kidneys, maybe a third of them. And lowering the uric acid probably requires taking the drug for several years to really see a benefit.
So from a medication standpoint, you mentioned losartan briefly, which is a high blood pressure medicine that can lower uric acid level.
Right.
Do you obviously we want to target uric acid with lifestyle, as we've been discussing, but do you also like to improve that with pharmaceutical medications?
Well, I tried initially to do it with basically lifestyle and things like vitamin C, which has very little controversy associated with it. If the patient has gout, if you have someone with gout, their uric acid should be lowered to less than 6 and maybe even lower if they have what's called tophi, which is uric acid deposits in the skin. Everyone agrees with this. The data is overwhelming. When you have gout, the crystals aren't just in the joints. You can find the crystals in the kidneys, as I mentioned, but there's even studies where they found them in the blood vessels, in the coronaries. In one study recently, they've developed a new type of CT scan so they can actually see the crystals by X-ray. And when they start looking at people, about 2/3 or more of people with gout has some crystals in their blood vessels, like their coronaries, and it correlates with increased risk for cardiovascular mortality and events and heart attacks. I mean, it's bad stuff. So if you have a history of gout, you should see your doctor. You should go on medication if you can't lower the uric acid with lifestyle alone, and get that uric acid under 6. And there's data showing that you're going to reduce your risk for death if you do that. You're going to reduce your risk for cardiovascular death. There's data suggesting it's also having a role in cancer. It just goes on and on. So if you have gout, definitely do it. Now we get into the controversy. Let's say you have a uric acid of 8, which is over 6, but you've never had an attack of gout. Well, about 20% of the time, you still have crystals in your blood vessels. So that's not good. So one could argue to get your uric acid down, just because we know that that you have silent crystals in your body. But here, the data isn't as strong that lowering uric acid is necessarily beneficial. They really need to do a good trial, with people at high risk, following, doing scans and all this stuff. But we just, at this point, it's mainly lifestyle recommendations for people with high uric acid in the absence of gout. But, between you and me, if you come to see me and your uric acid's like 8 or 9, I'm going to make the case that you would benefit having your uric acid lowered based upon, animal data, epidemiologic data, many clinical studies, but it's not proven to the point where it's FDA approved for that. And so it would require discussion, understanding the side effects and benefits, and it would be a kind of a decision together. But so I don't recommend people with high uric acid to just go out and go on uric acid lowering therapy. But if you think that it's you have a really high uric acid and you don't have gout, talk to your doctor. You can email me, and we can look at the pros and cons, and then you can make a decision. But you have to be very careful with uric acid lowering therapy, because some of them can be associated with side effects, and so we don't want you to get into any trouble.
Okay. Well, very interesting. Well, before we run out of time, I definitely want you to talk briefly about your latest book, which is Nature Wants Us to Be Fat. And I'm sure there's a lot of overlap with what you've been talking about, but give us just a kind of a general summary is what that book's about.
So when we found that fructose was so important in driving obesity, the more we studied it, the more we realized that it also had a role in other diseases like cancer, like alcoholism, like dementia, like behavioral disorders. And I realized it was important to get the book out to talk about, how fructose can be involved in all these different diseases, how it works, and to try to come up with a plan for people to how they can reduce their fructose exposure, how what they can do to reduce their risk for these these diseases. And at the same time, I wanted to explain the biology of how it worked. And it turns out that the biggest trick was when we started studying animals in the wild. And when we started doing that, we realized that fructose was used as a survival pathway to help animals survive, like winter for a hibernating bear and so forth. And then we as we understood it, we began to realize that this was a major process in nature that animals use, and that we have because we love sugar, and because our system taught us to love sugar, our taste buds and so forth, that we are actually trying to activate this switch all the time. And so the book talks about, the discovery, how it works, why it's specific to sugar and fructose, why, how it explains low carb diets and high protein diets, how it shows all these things. And then there's a lot of little tricks that when understand the mechanism, like, for example, eating slowly, why that works by decreasing the concentration of the fructose that hits the liver, why soft drinks are so much worse than solid sugar, how you can the benefits of hydration. We were able to show that water, increasing your water intake can actually reduce obesity, and we did studies in animals showing exactly how it works. So there's a lot of tricks in the book that I think people not everyone knows. And so I think that, that's why I wrote it. Also, we discovered that salty foods are really particularly active at stimulating sugar production in the body. They stimulate fructose. I mean, it was known years ago that if you go on a high salt diet, that you become insulin resistant within 4 or 5 days. No one really understood how that happened. Well, we actually identified how it happens from this fructose being produced. And then we were able to show that salt is actually another risk factor for obesity. And so when you're eating processed foods where they're adding salt and sugar to the food, it's like a double whammy. Yeah. So anyway, so there were a lot of surprises that came out of the work. So a lot of it also kind of corroborated, kind of confirmed what others have already been saying. I bet you that 99% of what you teach, is also consistent with what this book, comes to the conclusion. But it just gives a new insights into how to, how it works and what to do to prevent yourself from getting into trouble.
Yeah, very nice. So knowing what you've been, studying this stuff for a while and obviously doing a lot of research, and you're smarter than most of us. But with that being said, what do you eat in a day? What's a typical Dr. Johnson diet look like in a day?
Well, for example, in the morning, I'll have yogurt with a little bit of fruit, particularly berries. I like strawberries and blueberries. They have a lot of flavonols and fisetin and all these things that I know are good for me. I've shown that they can block some of the effects of fructose. I will, tend to eat keto bread if I have a toast. I like omega-3 rich foods. I'll have it, like today I had a salad for lunch, with chicken. I had a buffalo chicken salad. Maybe the buffalo sauce had a little too much salt, but and then at night I try to avoid high glycemic carbs. My wife is from Peru, and she loves rice, but I will tend to avoid the rice. And if there's potatoes, I will avoid the potatoes. I love, I'll eat vegetables. I like the most proteins, I try not to eat a lot of processed, red meats like bacon, salted ham. I try to avoid that. But I do have a diet that I in my book, but a low carb diet works great. Intermittent fasting works great, and kind of a wise diet where you kind of reduce the bad carbs, you allow yourself to eat good carbs, and you avoid the bad meats and you eat the good meats. That's sort of what I do. Snacks are a real problem. Those salted crackers and that people love to eat in the afternoon. And I used to eat that a lot. As I've learned the hard way from, reading and doing science, I've I've recognized that a lot of the foods that I, used to eat are not good for me. You know, geez, there was a day when I would eat nachos and all that kind of stuff. And I just try to avoid those now.
Yeah.
And the biggest difference for me is that exercise is such an important part of this. But when I was researching and doing clinical work, I had very little time for exercise, but I'm trying to do that more now.
Really interesting stuff. And so just really appreciate your time and all the work you do. As we wrap up here, I always ask my guests if they could give us one health tip that would make us healthier today. What would you say to that?
Drink a glass of water before each meal. Just when you sit down, make sure you get a glass of water and drink it first. It will actually help block the effects of salt that you're eating, and it will actually be working in your favor. And if you drink it right before you eat, that will have a very good positive impact.
Okay.
Greg, do you have something that you would like to propose, to suggest for me to follow? Oh, a website or any kind of, I know you're really into health.
Yeah.
What do you think is one of the best things that a person can do to help maintain their health?
Yeah. So probably the biggest advice I give people, and of course there's a lot of things, and you pretty much said it, but I tell people if they could eat food with one ingredient, if they could just do nothing else but do that one thing, eat food with one ingredient, I think it would just revolutionize their health.
Oh, you're right. Processed foods are really challenging because people add so much because they know that add this ingredient, it will stimulate them to like it more if you put a little salt, a little high fructose corn syrup. And you're totally right. Natural foods are so good. Only problem is they tend to be a little bit more expensive, but
that is true.
But what a great recommendation. Thank you.
Yeah. And obviously exercise is huge. And I used to always start with, the eat natural foods and then exercise, but it seems like the more I get into this and study, I don't know that exercise, might not be number one.
I love exercise has been my weakness because I'm just too busy, but I'm trying really hard to follow the recommendations that, we laid out based on the literature. I think everybody should be walking 30 to 45 minutes a day minimum.
Minimum.
And that's the starting point.
Yeah, that's for sure the starting point. And especially if somebody is doing nothing, I mean, you got to start somewhere. I really have been this year for sure. I've been pushing people to try to gain muscle, and unfortunately nature works against us in that with sarcopenia. But I feel like muscle is so important. Just for a number of reasons, but the metabolism and we've been talking about a continuous glucose monitor. And when I had mine, and I've, I love working out. I've always been into kind of bodybuilding and stuff, and I've got a fair amount of muscle. So with that, I think it helps me to be very metabolically healthy. And so anyways, I had on my continuous glucose monitor, and my wife is pretty strict low carb. And so I was trying to discover what elevated my blood sugar. And I was literally eating just whatever, and it wasn't going up. And anyway, I was telling my wife, I'm like, it don't matter what I eat, I can't change my blood sugar. And she was just giving me dirty looks, like, oh, shut up, and finally, it seems like I had, and again, I was just kind of experimenting with it for a couple of weeks, but I had a couple of pieces of cinnamon toast. I put a whole bunch of brown sugar on it. I think I put some honey on it and a glass of milk, and it finally bumped a little bit. And I was like, oh, okay, I found something that'll bump it up. But I say all that to say that I feel like that the more muscle you have, I think your body's just going to metabolize that sugar. Not that it's a license to cheat.
Absolutely true.
But if people could focus on that more, and exercise in general, but specifically building muscle, then I think that would help them get a long way in their journey for metabolic health. So,
We just published a paper where we could show that animals can develop metabolic syndrome. They also develop sarcopenia. And if we reverse this kind of uric acid pathway in their skeletal muscle, we can preserve their muscle mass. So, probably it's damage to the mitochondria that leads to sarcopenia. And so if you can keep healthy mitochondria, which exercise is the best thing to do for that. So fantastic.
Yeah. But anyways, well, good stuff. Well, certainly appreciate your time. I know you're a busy guy and researcher and clinician but just really appreciate all your expertise and coming on the show and sharing your knowledge.
Yeah, and it was great to talk to you, Greg, and thank you for your insights too.
Yeah, well, appreciate that. Well, appreciate everyone listening, and we will talk to you guys next time. Thank you for listening to FitRx. I invite you to share this with friends and family. If you would like, you can check out our website at vibrantlifedc.com, or you can email me at drgreg@vibrantlifedc.com.